Good evening. Welcome to today's problem solving session. Uh, I think Ratish, you're the only one, so we'll wait for a couple of more minutes to allow participants to join. Okay, so I think we'll start the session for today. And let's let the others join the course of time. So today is the third week of the problem solving session. Like all the time, we'll be discussing some problems that are associated with the portions that were taken during the third week of the lecture series, which includes lectures from 10 to 14, dealing with Vadose zone and saturated zone. If possible, can someone just confirm by chat or by switching your mic on if my voice is audible and is my screen visible? Okay, thank you, Ratish. We'll be dealing with the questions that are related to Vadose zone and the saturated zone. Also a reminder, you'll be required to submit the third assignment, that is dealing with the questions from week 3 on the 14th of August and the assignment 4 on 21st August. Also, the assignment 1 and 2 solutions are out, so you can cross-verify with the solutions about how you have performed in the assignments. I have also taken a few questions from the assignment 1 for discussion. That wasn't I mean some few questions that numericals and other questions that we weren't able to, the kind of questions we weren't able to discuss during the problem solving session. So for today's session, we'll be doing that also. So like always, I'll be showing some questions on the screen. You need to put in your answers in the chat box, and I request you that we make it as interactive as possible so that it is not boring for both you and me. So we'll start with today's problem solving session. Um, Before going into the problem solving session, like I said, today's session is on Vadose zone and the saturated zone. So most of the questions are based on this. So to give a brief idea or a reminder of what is the lecture series all about, it is about the segregation of the subsurface into different layers. Now, majorly, it is classified or segregated into two layers. One is the saturated zone and the other is the unsaturated zone or the Vadose zone. Now, saturated zone, as you see here, the zone of saturation is that zone which is below the water table, and all the soil depths above the water table comes under the unsaturated zone, or it is also called as the zone of aeration, or it is also called as the Vadose zone. Now, within this zone of aeration or Vadose zone or unsaturated zone, the depth of the soil or that layers of the soil are further divided, segregated into three layers. One is the initial zone is the zone of soil water or soil moisture. It is also called the root zone. This is the zone where the infiltration will happen. As soon as it precipitates, water will infiltrate into this part of the soil, and it is only after the this portion of the soil is saturated to an extent that water starts moving downwards. So this is the soil water zone. In the unsaturated zone, the soil water zone or root zone is considered to be the saturated layer in this unsaturated zone. Then just below the soil water zone, you can find the intermediate Vadose water or the intermediate Vadose zone. And after that comes the fringe layer or layer where water, you can see water as a result of capillary action uh, in the soil, and the water is being, as a result of capillary action, water from the water table will move upwards into this layer. So in comparison to this layer will be having some water as a result of capillary action. So the zone where water exists as a result of the capillary action of water from the water table is called the capillary fringe. So these are the three divisions of the Vadose zone or zone of aeration or unsaturated zone. And this zone of saturation is called the saturated zone or groundwater, phreatic water zone, water table zone, all those. So this is basically what the whole of this today, this lecture and the problem solving sessions are based on. So we'll move to this was just a rough idea about what is the classifications of the subsurface in terms of saturation and unsaturation. So moving to the first question, please put in your answers in the chat box. The water which in a state of downward movement under gravity is called as what? The water which is in a state of downward movement under gravity is called what? Is it called groundwater? Is it called Vadose water, connate water, or juvenile water? As of now, Ratish and Hanumanta are only there, so you can just put in your answer, whichever you feel are right. Okay. Okay. So Ratish says it's A. Hanumanta says it's B. So let's check what the answer is. So the correct answer is B. Now, groundwater is the water that you see from the water table to below. So that water is as a result of accumulation of the water that is moving down from the initial layers of the soil deeply and reaching the water table. Now, Vadose water is that water which actually goes down initially and saturates the soil water zone, and then again, as a result of various pressure, energy levels of the water, it further goes down into the groundwater. So, correct answer is Vadose zone. Here again, there are two other terms, connate water and juvenile water. Connate waters are liquids that were trapped in the pores of sedimentary rocks when they were deposited itself. And they not only contain water, but they contain a lot of mineral composition also in the solution form. So that is what is called as connate water, water that was already existing in the pores of sedimentary rocks, which have formed the aquifer. They have not come in as a result of downward movement of water from the precipitation. Juvenile water is magmatic water that is originating in the interiors of the earth and associated with the magmatic activities. Magmatic activity is nothing but activities that are occurring within the core of the earth's surface, the cooling, the heating, and as a result of that, water particles that are formed that will stay within the rocks or whatever rocks that are formed within the core of the earth is called as juvenile water. So the answer for this question will be Vadose water, water that is getting initially moving down in the first few layers of the soil is called Vadose water. Now, what is the process of downward movements of Vadose water called? It's downward movement of Vadose water, not movement downwards of Vadose water. I'll do the correction and submit the slide. What is the process of downward movements of Vadose water called? Okay, Ratish says it's A. Is it called infiltration, filtration, deposition, or downflow? Okay, both of you are saying A. So let's see what the correct answer is. So the correct answer is A. We had learned in the previous classes also, particularly in the first week, what are the various components of the hydrological cycle. And one important component of the hydrological cycle is infiltration. Infiltration is the downward movement of water when precipitation or rainfall, it reaches the earth's surface. When water enters the subsurface of the earth, then that downward movement of water is called infiltration. Again, as this water travels into deeper layers of the soil, it is called percolation. Filtration is a process where the water is filtered off its bigger particles or unnecessary particles. Deposition, you know. Downflow is again just a term that we use for the downward movement of water anywhere. It's not particularly limited to the movement of water in the soil. So that was the second question. Now moving on to the third question. What is the upper surface of the saturation zone called? So Hanumanta saying it's C. What about you, Ratish? Okay, Ratish already said. What is the upper surface of the saturated zone called? So this was, I had initially explained a bit about the saturation zone and unsaturated zone. So okay, let's move on to the answer. So the upper surface of the saturation zone is called the water table. Earlier I had shown two zones that we are talking about. One is the Vadose zone, and the zone that is below the Vadose zone is the zone of saturation. Zone of saturation is where the soil layer is completely saturated with water, and top of that water surface is called water table. So water table is forming the boundary between this Vadose zone and the zone of saturation. So the upper surface of the saturation zone, as you see here, is the water table. On top of the water table, you see the capillary fringe. On top of that, here will be the intermediate soil water, intermediate Vadose zone. And on top of that will be the soil water or soil moisture or root zone. So this is the answer for the third question. This week's lecture is pretty simple as in comparison to the earlier 2 weeks. So yeah, I don't think it will be much difficult for you to solve the assignment 3 as well. Now, groundwater is not safer than other sources of water. Is this statement true or false? Is groundwater safer than other sources of water or not safe? Here, Ratish and Hanumanta says it's B. So here they are asking if saying that groundwater is not safer than the other sources of water, which is false, because groundwater has the advantage of being collected as a result of movement through various layers of the soil. So to some extent, a filtration process is happening, which is a filtration process happens, which kind of makes it more safer than the surface water on surface water bodies, because surface water bodies is always in a state of exposure to pollution, biological, chemical, physical, what so many kinds of pollution. But in case of groundwater, other than the fact that groundwater is also being polluted as a result of contaminant transport, but in comparison to surface water, the pollution content of pollution exposure of groundwater is much, much lesser. So the statement here is false. Moving on to the fifth question. The Vadose water, which is lost to the atmosphere by transpiration and evaporation, is termed as what? What is that water in various layer in the layer of the soil that is lost by evapotranspiration? Is it the soil water, intermediate water, phreatic water, or the water table? Okay, Hanumanta, do put in your answer too. Okay. So Hanumanta has also given answer A. So let's see what's the solution for this question. So here they're talking about which water from the soil is usually going back into the atmosphere in the form of evapotranspiration. So definitely it is the water at this surface. So mm, this is the water that is exposed or is nearest to the atmospheric layers. So as a result of that, when the temperature in the soil increases, or as when the roots are going to absorb the soil from this, absorb the water from this layer and then going to release it into the atmosphere in the form of transpiration. Not only that, the water in this layer of the soil is more exposed or more prone to get evaporated, not the water table. Water table is at several meters of depth below the surface of the soil. So the water table doesn't get evaporated into the atmosphere. There will be vapor transport here from the water table, but that's an entirely different story. Into the atmosphere, it is water from the soil water zone that is always getting evaporated and transpirated. So intermediate water is also below the soil water. Phreatic water and water table are both the same. It is groundwater. So the correct answer in case of this question is option A, soil water. Okay, moving on to the next question. Which zone is a zone of non-saturation among the Vadose water? So Vadose zone itself is a non-saturated zone. In that itself, like I said earlier, we classified into three layers, and within that there is a saturated layer and non-saturated layer. And you compare all the three layers within the Vadose zone. So which layer out of that is the non-saturated layer? Is it the soil water layer, intermediate, or phreatic water, or the water table? Okay, great. One says it's A, one another says it's C. So let's check what the answer is. So, like I said, the soil water zone has is the saturated layer in this zone of aeration or unsaturated zone. Uh, you should always be careful about not getting confused between the saturated zone in Vadose zone and the zone of saturation. Zone of saturation is the name that is assigned to that layer below the water table where it is fully saturated with water. In the case of the layer that is above the water table, which is the Vadose zone, whose other names are zone of aeration and unsaturated zone, there are three classification. In that three segregation or segregation of the layers, the first zone is first saturated with water because all the water that is coming onto the surface will first flow into this zone. It is only after that it will start, after this layer is saturated, that the water will start moving down into the intermediate Vadose zone. And fringe water, the capillary fringe is the layer which has got most of the water as a result of capillary action of uh, capillary action of the soil over here as because of this water table. So the first layer is always saturated, the second layer is unsaturated, and third layer is a mixture of air as well as water, the capillary layer. So the zone of non-saturation in the Vadose zone or Vadose water zone is the intermediate zone, because the soil water layer is going to be the one which is saturated, and it is only after that the water will come down. So comparatively, this zone is going to have the least saturation, or most of the time it is non-saturated. So the correct answer is intermediate water zone. It is the zone of non-saturation among Vadose zone. So whenever they talk about Vadose water or zone of aeration or unsaturated zone, it means this part of the subsurface profile. So always keep in mind, don't please get confused with the zone of saturation and the saturated zone in Vadose zone. If there's any doubt and you want more clarification in that, please let me know. Moving on to the next question. Good evening, Arif. Please do join in posting your answers for the questions coming. Yeah, so this is an explanation of that. This water table zone is the saturated zone, and this is the unsaturated zone or aeration zone or a Vadose zone. In that, there are three zones: soil water, intermediate, and capillary fringe. This is the saturated zone in the zone of aeration. This is the unsaturated zone in the zone of aeration. And this layer will consist of water as well as air particles. So it is not fully saturated, neither is it unsaturated. Moving on to the next question. Which zones are collectively known as a zone of aeration? So there is A and there is B. So let's see what. So which zones are collectively known as the zone of aeration? Actually, there's a mistake in the options. I'm sorry about that. Uh, the zone of aeration collectively will be the soil water intermediate zone and the zone of capillary water. So none of the options cover that. So I think one of the options needed to be that. So the answer here will be soil water intermediate zone as well as zone of capillary water, not just these two layers. Here, the soil water intermediate zone and the capillary fringe will create will is collectively is called the zone of aeration. But since I've wrongly provided the options as just two of the layers, so none of the options are correct. It is soil water intermediate zone and capillary water. So I'll change this question before posting, but the correct answer would be these three layers. None of the options are right in the case of this question. Um, Okay, I hope that idea is clear because since you put in the answer A and B, probably it is because you were confused since one option was not there. Is this classification clear with all of you? Okay, in the further questions that will come, we'll discuss more about this. So I think it'll be more clear. Okay, moving on to the next question. The zone of water which occurs only in fine particle size is soil water, intermediate phreatic water, or zone of capillary water. So the zone of water which occurs only in the layer where there are fine sized particles is called what? Is it the soil water zone, intermediate water, phreatic water, or zone of capillary fringe? Okay, one says it's B, another says it's A. What is Ratish saying? Okay, let's move to the answer. So the correct answer is D. It is in the fine particles that there will be small pores. And as a result, when these pores are all, when these pores are coming one over the other, it is through these line of pores or this path of pores that water enters as a result of capillary action. So, zone of capillary water or the capillary fringe is where you will find fine size particles with pore spaces that acts as these tubes through which water can enter as a result of capillary action. And you can see that we know that coarse soil like sand, even though they have pore spaces, the water will very suddenly move through them. There won't be any storage of water in coarse grained soils. So that is because the pore spaces are huge and there's no much attraction from the particles of the soil with water. So as a result of that, it's water is easy to move through this. But in case of clay particles, clay is exerting attraction on the water particles as a result of which is a capillary action and water stays in that layer because of these fine size particles like clay. So the correct answer is zone of capillary water. Okay, moving on. You're not taking. I didn't understand. You're not taking my name, please. Okay. I'm not very clear about what you mean in here, but yeah, we move on. Okay, question 9. Which Vadose water zone is also called the zone of saturation? Again, this is one somewhat like a trick question. We had discussed another thing earlier. It is the opposite of that. So, which Vadose water zone is also called the zone of saturation? We are talking about the zones or the layers in the Vadose water zone. Phreatic water is what RF is saying. Ratish and Hanumanta, you can also put in your answers. Okay, there's one C, one D, and one B, which unfortunately none of them. Which Vadose water zone is also called the zone of saturation. Okay. Okay, again, this question is a bit confusing. Here it is written Vadose water zone. Vadose water zone is the zone of aeration. And in the zone of aeration, the soil water is actually the saturated zone. But again, since it's zone of saturation that is being talked about over here, phreatic water, again, this question is a bit confusing. Um, I'm glad it was, I mean, I hope it was not confusing to you, but this seems like a bit confusing because they're telling which Vadose water zone. So Vadose zone is the zone of aeration or unsaturated zone. In that zone, the saturated layer is the soil water zone. But if it is the sub profile of the soil and zone of saturation will be the phreatic water zone or the water table. So again, I'll have to reframe this question. Yeah. Okay. Okay. Moving on. A local water table that is positioned above the regional water table is called stranded, perched, displaced, or depressed. Okay, Ratish is saying it's B, Hanumanta B. Okay, okay. So moving on to the answer. Yeah, the correct answer is B. We had learned in the aquifers there's something called a perched aquifer, where when it rains, there are some confined layers or impermeable layers that are coming in between unconfined aquifers, and water will get accumulated in that and form a local water table. It is not actually a very deep water table, but a layer of water that is formed in on top of a um, of a formation of impermeable layer, which is called a perched aquifer. So here that local water table is also called a perched water table. Moving on, so this is what the perched aquifer looks like. This is an impermeable formation in the middle of an unconfined aquifer, and in that there is water being accumulated, and this water is called perched water table. Okay, moving on. What is the other name for the Vadose zone? Is it saturated zone, unsaturated zone, phreatic zone, or zone of saturation? Okay, so I've got two answers. Yes, right. So the correct answer is unsaturated zone, saturated zone, phreatic zone, zone of saturation. All of these are different names for the zone of saturation. Vadose zone is unsaturated zone, zone of aeration, or Vadose zone. These are the different names for the Vadose zone. Moving on to the next question. What is the area where groundwater is drawn up into the pores and spaces in the sediment called as? In the subsurface profile, what layer or what is the area where the groundwater is drawn up into the pores as a result of pore spaces in the sediment called as intermediate, soil water table, or capillary fringe? Okay, I've got one A, one C. Hanumanta, you can also put in your answer. Okay. So there are two C's and one A, both of which are wrong answer. The correct answer is D. So we had discussed earlier how the water goes up from the water table as a result of the capillary action. Capillary action is again because of the pore spaces that are available in the soil particle over here. These pore spaces, which when they are forming a path, they take up water from the water table as a result of the capillary action or the molecular attraction of these particles that are forming the pores. So this zone is called the capillary fringe, and this water is called the fringe water. So the correct answer is capillary fringe. And water table is the upper surface of the water that is separating the Vadose zone and the zone of saturation. And soil water, intermediate zone also, So the correct answer is option D. Now, what zone in the unsaturated zone is the most important for agriculture? Okay, so let's go on to the answer. The correct answer is the soil water zone. Like I said, I had mentioned earlier, the soil water zone is also called the root zone. This is the zone where roots will extend and the roots absorb or take in water that is required for their growth. So the most important layer in the unsaturated zone that is significant to plants and in agriculture is the soil water zone. Another name of soil water zone is also called the root zone. So please keep that in mind. Okay, moving. You can type in your answers in the chat box. What are the three subzone classifications in the soil water zone? Okay, so I've got both of your answers. Soil water, intermediate, and fringe or capillary fringe. So here we are talking about the soil classifications in the soil water zone. We're not talking about the classification of the Vadose zone. So water zone, that is the root zone, was again classified by Briggs into further three subzones, depending on what is the concentration of moisture uh, in the soil. And those three zones are called the hygroscopic water, capillary water, and the gravitational water. So hygroscopic water is nothing but it is the water that cannot be taken up by the plants. So hygroscopic water, they are very much attached to the particles, and this water cannot be removed because it cannot be removed in any way. It cannot be removed by gravitation, or it cannot, if even if plants try to absorb this water, that water is not going to go. So such water particles are called hygroscopic water. It is very much forming a layer around the soil particles. And most of the time, if that water is being removed from the soil, it will be due to vapor. So it is unavailable for any use. Now, capillary water, again, the water that is held in pores, again in the soil water zone, when there are pores together as a result of capillary action, at a very minor level, not as much as you see in the capillary fringe, but within the soil water zone also, there are some water particles that are existing as a result of capillary action of the soil. And gravitational water is the water that is easy to flow downwards. So soil water zone is again divided into three subzones depending on which all parts of that soil water zone has the hygroscopic water. Some parts of the portions of the water has got capillary water, and some portions of the soil, that layer of zone, has got water that flows as a result of gravity. So this is not a correct layer by layer classification of that soil, but within soil water zone itself, there will be water particles which are very much adhered to the soil particles. There will be water particles existing as a result of capillary action, and there will be water that moves as a result of gravity. So all these three types of water movement is there, and it is based on those portions of the soil that has this hygroscopic water, capillary water, and gravitational water are again divided into three subzones within the soil water zone. So what you have to be careful about here is Three subzone classification in the soil water zone. The question that was asked is about the soil water zone and not about the Vadose zone. If it is the Vadose zone that we were talking, whatever answer that you gave us, right? It is soil water, intermediate and capillary fringe. But the classification of soil water zone is based on the classification by Briggs, and it is hygroscopic, capillary and gravitational water. So that was about the question 14. Moving on to question 15. Which instrument is used to measure the soil moisture percentage? Is it a tensiometer, piezometer, hydrometer, or a barometer? Okay, so yeah. One says it's C, one says it's A. Let's see what the correct answer is. So the correct answer is tensiometer. Tensiometer is used for measuring the soil moisture percentage. A piezometer is a device that measures pressure. Hydrometer is a device that measures the density or specific gravity of a liquid. And barometer is again a pressure measuring device, mostly atmospheric pressure. So the correct answer is tensiometer. Tensiometer is what measures soil moisture percent, soil water content or soil moisture. So yeah, again, this is a new point. So this is what a tensiometer looks like. It is inserted into the soil, and yeah, this picture pretty much describes how the moisture content is obtained. Okay, moving on to the next question. Which model is commonly used to assess aquifer vulnerabilities by considering parameters like depth to the water table, hydraulic conductivity, and net recharge? Is it the Hydrus model, WQI model, drastic, or SWML? Okay, so one says it's C, one another says it's A. Let's see what is the correct option. So the correct answer is the drastic model. Let's have a look at all these models are. So Hydrus model is a model that simulates the water, heat, and solute transport in one dimension, two dimension, and three dimension through variably saturated media. Can be through fully saturated, unsaturated, partially saturated media. So it is simulating how water moves, how heat moves, and how solute moves in soil. Now, WQI is water quality index model. It is to quantify the water pollution in surface water. Drastic model is the model that we are talking about. It is a model that helps in groundwater vulnerability assessment. It is including seven important parameters that we require to give us an input. The depth to water, what is the net recharge of the aquifer, what is the aquifer media, what is the soil material that is forming the aquifer, what is topography of that land area, what is the impact of the Vadose zone and hydraulic conductivity of the material. And SWMM model is stormwater management model. Again, it is used for analysis, planning analysis and design related to runoff water in sewage and drainage system. So drastic model is a model that is associated with groundwater vulnerability assessment. Moving on to the next question. Which zone holds water that is available to plant roots? Is it saturated zone, capillary zone, soil moisture zone, or intermediate zone? Okay, both of you have given the right answer. So it is soil moisture zone. So we had discussed about the three initially which zone is important for agricultural purposes, agricultural crops. It is the soil water zone. Another name for soil water zone is the soil moisture zone. It is also called the root zone. So the correct answer for this question is soil moisture zone, as both of you have said. Moving on to the next question. Which zone is responsible for filtering precipitated water before it reaches the zone of saturation? So the capillary zone, saturated zone, Vadose zone, or intermediate zone. Correct. This has the probability of being a little confusing because there might be a lot of people who might wonder it is the intermediate zone because yeah, but both of you have given the correct answer. It is the Vadose zone. So the zone that is above the saturated zone, which is the Vadose zone, it has water that is actually passing through three different layers before it reaches the water table. So in process of that movement of downward movement of water, there will be a lot of filtration processes occur. So the correct answer is the Vadose zone. Moving on to the next question. The Vadose water, which is lost to the atmosphere by transpiration and evaporation, is known as. This is a repetition, but I hope you will be able to answer this. Correct. Both of your answers are right. It is the soil water zone. We had discussed this earlier also. It's the root zone or soil moisture zone. It is the layer that is very important to plants as well agriculture. And it is through this zone that water is taken up by plants, and also water that is evaporated into the atmosphere is mostly from the soil water zone. The 20th question, which zone is extending from the top of the ground surface to the water table? Okay, Arif says it's D. Hanumanta is saying it's A. So the question here is, which is the zone that is extending from the top of the ground surface to the water table? And the correct answer is Vadose zone. So if you remember the diagram that I had shown, the surface of the ground until the water table is the Vadose zone. Water table to below is the saturated zone. So the correct answer here is Vadose zone A. Capillary zone is that zone where water is entering from the water table upwards as a result of capillary action. Okay, you may put in your answers. We'll also take a break of 2 or 3 minutes. Uh, Meanwhile, so please put in your answer for this question. What is the term used to describe the thin layer of water that is adhered to the soil particles that is available for any use? That is unavailable for any use. We had discussed this. Is it capillary water, gravitational water, hygroscopic water, or infiltrated water? We'll meet again. You can put in your answers here. We'll discuss the answers in a couple of minutes. I'll be getting back to you by 7:02. In It's 6:58 now. After 5 minutes. 4:73. Okay, so welcome back to the class. Um, so we were discussing this question. What is the term that is used to describe the thin layer of water that is adhered to the soil particles and that is unavailable for any use? The correct answer is hygroscopic water. I had mentioned earlier about three subzones of classification. Yeah. Hygroscopic water, capillary water, and gravitational water. Hygroscopic water is the water which is existing in the soil as a result of strong molecular attraction of the soil particles, and it exists as a small layer around the particles. This water cannot be absorbed by the roots, or it is not moving from one place to another as a result of gradient, because the attraction of the particles to this water is very high. And this such water exists as a thin layer around the particle, and it is called hygroscopic water. So correct answer for this question is hygroscopic water. We learned about what capillary water is, gravitational water is. Infiltration water is just a term for saying that whatever water is infiltrated. So next question, what is the primary mechanism by which water moves through the Vadose zone? Is it the infiltration, evaporation, capillary action, or groundwater flow? Which is the main mechanism through which water is moving through the Vadose zone? Okay, so moving on to the answer for this question, the primary mechanism by which water moves through the Vadose zone is infiltration. Evaporation is a process where water is moving upwards. Capillary action is again the mechanism through which water is existing because of the action of the presence of the pores. Groundwater flow is nothing but the either it is a lateral movement of water, water in the water table. So correct answer is A. Moving to the next question. What is the term that is used to describe the area above the water table where soil pores contain both air and water? Hanumanta Arif, you can put in your answers in the chat box. What is the term that is used to describe the area above the water table where soil pores contain both air and water? Okay. So the correct answer for this is the uh, capillary zone. The answer that you gave. Yeah, I'm sorry, this answer is wrong. I mean, what is given in the here is wrong. It is capillary zone. The what just above the water table, we have the capillary zone. Water is existing in there as well as air is there because in the pore spaces. I'll be definitely correcting this part and uploading uh, the document after doing the correction. So correct answer here is A, not C. It is the capillary zone. Moving on to the next question. What type of rocks are found in the groundwater potential zones in Karnataka? Okay. Okay. I think the answer is given here. So let's move on to the discussion. So this is one part which is covered, I think, in the week 1 or week 2. There are some groundwater potential zones that are discussed in all over India in the lecture series. So I just wanted to um, discuss that once more in detail. So let's move on to one by one of these groundwater potential zones that have been discussed. So there are around 10 to 15 groundwater potential zones that are discussed in your portions. First one is the springs in the Himalayan highland. The main point over there, so the question is going to come like this: what types of rocks are found in the groundwater potential zones in Karnataka? The correct answer is granitic gneisses or schists. Now, coarse sand, gravel, and boulder of thickness is found in one particular area. Lignite or carbonaceous clays are found in one particular area. Lenses of sand and gravel are found in another particular area. Then, so let's see what all are the key points of all these areas. So springs in Himalayan highlands, they are consisting of all types of rocks. Some takeaway points here is that the alluvial deposits in there are 30-meter deep and they have waters which are soft water, not hard water. So if there's a question that comes where they say that what are the main deposits in the groundwater potential zones in the Himalayan highlands, it is mostly alluvial deposits that are 30-meter in depth. And also the water there you find is soft water. And you find almost all types of rock over there. Granites, basalt, sandstone, limestone, shales, igneous, sedimentary, metamorphic, all of them are available over there. Spring is a major source of water in the Himalayan highlands. Now, in case of freshwater sediments of Kashmir Valley, this is another very potential groundwater potential zone. And here, this Kashmir Valley consists of freshwater sediments from lakes, rivers, and glacial deposits. This is another key point in case of the freshwater sediments of Kashmir Valley. So if a question is coming as to what are the kinds of deposits that you find in Kashmir Valley, they are freshwater sediments, basically from sources of freshwater like lakes, rivers, and glaciers. The sediments that are deposited from by lakes, rivers, and glaciers. Then they are discussing about Indo-Gangetic plains. Indo-Gangetic plains are the plains that is getting the deposits from the Indus, Ganga, and Brahmaputra river. So one very key factor in this zone, which is having a huge potential of groundwater, is that the water, it's fresh water, which is sweet, and they consist of coarse sand, gravel, and boulders of the thickness 6 to 3 to 60 meter, and the water is commonly hard over there. We had discussed how the water in Himalayan highlands are soft water, but in Indo-Gangetic plains, the water is hard water, and they have mostly coarse soil, like coarse grain soil. There are gravel, there are boulders also. Leaky aquifers are there. And the key point here is that the water is kind of fresh and sweet. Then we are discussing about, I think I have, this is the Indo-Gangetic Plains. This is the area that has the deposits from Ganga, Brahmaputra, and Indus Valley, Indus rivers. In the other place is the coastal alluvium. Coastal alluvium is the soil or the aquifer or the groundwater that is existing in the coastal areas of India. There are two coastal plains. One is the western coast and one is the eastern coast. The eastern coast is comprising of the Coromandel coast. Western coast is comprising of the Malabar and the Konkan coast. So in this coastal areas, there is something called tertiary aquifer with lignite or carbonaceous clay. So this question has one option, lignite or carbonaceous clay. So this is found in areas of the coastal areas, particularly in Malabar and Coromandel coast. And here they have also said that these places in the coastal areas, they have saline patches. That obviously, since it's a coastal area, there'll be salt water. So saline patches are found in Ramnath, Tirunelveli, Ongole, Nellore, and Krishna districts. So some key points in this coastal alluvium is the presence of saline patches and lignite and carbonaceous clays. Then in the next one, they're talking about Cretaceous sandstones of Kathiawar and Kutch areas. Cretaceous sandstones are such formations. These are sandstones that are having this kind of chroma color, and it is found in the Kathiawar and Kutch areas in Gujarat. And there is nothing very specific to it, but again, what kind of stone rocks or stones are found in Kathiawar and Kutch areas, you can there can be an option called Cretaceous sandstone. So that is one point you can study for this area. Then there is Lathi region, including Jaisalmer, Barmer, and Bikaner. They have Mesozoic sandstones in there. Mesozoic sandstone or the Lathi formation is this formation in India, which has the fossil remains of dinosaur. It is a this particular formation is found in India only. And this Mesozoic sandstone is consisting of these types of rocks and also minerals along with these materials. So this is just what Mesozoic sandstones mean. And so this formation is found only in India in these regions. No, sorry, the Lathi region is, I think, it is in Rajasthan, not in Gujarat. Then we have Doon Valley, gravels. So Doon Valley is again, where is Doon? Doon Valley is in Uttarakhand. So this is Uttarakhand, and in this place over here is called Doon Valley. So Doon Valley is consisting of boulders, pebbles, gravel, sand, and clay. So if anything associated with Doon Valley comes, you should remember it will be gravels that are present there. Then there is quaternary alluvium. That is, quaternary alluvium is lenses of sand and gravel. These are found in the regions of Narmada, Purna, Tapti, Champal, and Mahanadi rivers. This alluvial what is this quaternary alluvium is nothing but this alluvium developed when stream bed deposits and contains layers of gravel mixed with fine sand. So lenses of sand and gravel is found in this region, and it is called quaternary alluvium. So these are names that you can remember and associate and the corresponding places to it. There's nothing, no other way but try to keep it in mind. Then there is vesicular basalts in the Deccan Trap of Maharashtra and Madhya Pradesh. So this is the Deccan Trap, covering almost all of Maharashtra and a huge portion of Madhya Pradesh. And this is how vesicular basalt is. Basalts are nothing but igneous rocks. So when this rocks that are formed as a result of magma, cooling of magma, there are some gases that are trapped in between these formations. These gases, they won't burst, but they'll remain trapped in the form of bubbles and later on form such pores that you see in the pictures. So these are called vesicular pores, and this basalt rocks are called vesicular basalt. Yeah. Then there is and they are found in, yeah, here they're saying in Satpura range and Malwa plateau are these vesicular basalts found. So if these if you Malwa Satpura range is this range of mountains that is stretching from the north of Maharashtra to the south of Madhya Pradesh, and Malwa plateau is this area in Madhya Pradesh. So these are the two regions where you find vesicular basalt. I haven't got any much content regarding this. I think I'll be putting this in the next classes slides. There are carbonate rocks with solution cavities in Madhya Pradesh, Dharwarian, and I'll put in some details about all these options in the next class. I couldn't get much material. So we'll be definitely discussing some more, or I'll put in the slides itself. I just couldn't get much material. Again, quaternary sediments is what we had discussed earlier. For Narmada, uh, there were a few rivers, Narmada, Tapti, Champal, and Mahanadi. These quaternary sediments that is also found in deltas of Digha, Midnapur, West Bengal districts. I'll be putting in details about all these things in the next class. Uh, these as well. Granitic gneisses and schists of Karnataka are what is found in the Deccan Trap. Again, the Deccan Trap is this region that I have told. And also in Karnataka, you find this particular type of rock, granitic gneisses and schist. Yeah. So some more details about these 10 to 17, I'll be putting in the next class. Now moving on, we'll move to some of the few questions that we could discuss in assignment 1. These are numericals. So please check this problem, calculate it and put in your answers in the chat box. Given that the precipitation in the area is 800 mm and the runoff is 50 centimeter, how do we calculate the evaporation? Please put in your answers, Hanumanta and Arif. Evaporation calculation forgot. Okay. Okay. So we had talked about the water budget equation. Now, the whole concept of water budget equation is that whatever water is coming as input is always going out as output. If there's any change in the quantities, it is because water is being stored somewhere. Now, here they are giving us three quantities: precipitation, which is an input, and runoff, which is an output, inflow and outflow. But whatever precipitation, which is 800 mm is coming, is not going off as runoff. Only 550 centimeters, which is 500 mm is going off as runoff. So there is some amount of water that is remaining, and they have asked us to calculate the evaporation. So from that, we have to understand that the water which is going as 500 mm of water that is going as runoff, the remaining water will be evaporation. And in order to calculate what the evaporation is, we just subtract the outflow from the inflow. So inflow is 800 mm. Outflow is actually a sum of the runoff and evaporation, because in this question they have just given those three parameters. So this three parameters or this three processes is what is being discussed right now in this particular question. So um, you have to comprehend it in that way, and then subtract the runoff, the outflow components, which are runoff and evaporation from precipitation. So this is simple numerical. It's only a matter, I mean, you we studied the water budget equation, but we didn't do problems like these. So I just wanted to bring an idea into that part where you have to calculate the outflow component by getting by whatever components are given in this. Okay. Now, next question. Which of the following is a measure to improve agricultural water use efficiency? Okay, AA, that's correct. Agricultural water use efficiency, drip irrigation, right? So, installing low flow toilets would be water management for domestic or municipal waters or commercial water. Rainwater harvesting, again, definitely for uh, the what to say, in areas of residence or commercial areas, you can make use of the precipitation water from rain. Then industrial wastewater, reusing industrial wastewater will be an industrial wastewater management. So in agriculture, drip irrigation is one that helps us in managing the water resources without wastage. What does the acronym AMRIT stand for? Is it okay? So it is Atal Mission for Regeneration and Urban Transformation. We had learned about two programs like this. One is the Amrit and the other one is the JGN, Jal Jeevan Mission. Amrit is one which is taking care of all of the design of water structures, wastewater structures, stormwater drainage, uh, and all of the infrastructures required for water management in cities and towns. Jal Jeevan Mission aims at providing individual household tap connections to all the household in rural India. So these are two important things that are being discussed in the lecture series. So that is why I wanted to again bring your attention into these two, this problem. Again, this question, what is the, okay, this is the correct answer. Now, this one, in a reservoir, it is given that the seepage loss is 30 mm, precipitation is 20 centimeter, evaporation is 10 centimeter, calculate the change in storage. So here we are asked to calculate the change in storage, which we are familiar with. Because seepage loss is an outflow, precipitation is an inflow, evaporation is an outflow. So what will be the change in storage? The only thing that you need to be careful about here is the units. Here loss is given in 30 mm, precipitation in centimeter, evaporation in centimeter, and all of the answers in meter. So it is important that you submit your answers in the form by being careful about the units. The unit is one common error that a lot of people make, converting the units. Anuvanta, should I wait for your answer? Okay, so it's a simple numerical. Let's just check what the answer is. So we know the water balance equation, change in storage is equal to inflow minus outflow. Like I said, inflow is precipitation, seepage loss and evaporation is outflow. Inflow is given in centimeter. So convert outflow also into centimeter. This becomes 3 centimeter and this we know is 10 centimeter, which is 13. So we get um 20 minus 13, 7 centimeter. And here, since the answer is all in meter, we need to convert it to meters, which is divided by 100. So you get 0.07 meters. So this is the correct answer. This will be for today. I'll be here till around 8 o'clock. If you have any doubts, feel free to ask. And else, if you don't have any doubts, you are free to leave the meeting. Thank you for attending today's session. Thank you, Anand. Thank you, Harish. If there's any doubt, you can exit the session. My sessions are scheduled for Tuesday 6 to 8. I will not be able to change the timings. Hanumanta and Arif, if there are no more doubts, you can exit the session.